Hello viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about why building O'Neill cylinder part 2. So let's dive deep into it. Now this is continuation of part 1. I'm hoping that you have seen part 1 on last Monday. So let's dive deep into it. Now the whole essence of it is basically we have to go and grow in perpetuity, as in ever expanding. But we can't do that on Earth, and that is factually true that Earth has a limited surface area. Earth has a limited carrying capacity in all other vectors. So fundamentally that system is more of like a cradle. Like Earth is like a cradle world which gets you started, but it's like, bro, you gotta leave the nest at some point. Now anytime we are talking about expansion, people say, where is the space? But here's the funny thing. If you take 10 trillion people, right, 10 trillion human, and give them enough a volume that they can work with, there will be still more than enough space left in space. There is a lot of space in space, and plus it also has energy. Meaning, if you go back like with a time machine in the previous early ages of human civilization, you will find a very unique trend is we were always around where there were river. Why? We did not knew how to do farming on our own term. We had to rely on nature's term. Nature is like, there's the river, there's the delta, it's fertile, go YOLO on it. But anywhere else you could not. But as our technology grew, we started to handle that. Basically, the unreached parts, the central parts of the countries started to become accessible. Hot parts of the country became livable simply because of better air conditioning and all that jazz. So brick by brick, we solved all these issues. Now, what is the upper limit of that? Like where is the end point? End point is space and energy. And right now, sun is like, we got you, fam. Sun is like, bro, I got you. Energy is like, you do not have to worry about energy once you are in space, like especially in Earth's point. And again, once you start to get closer, there's more than enough energy. Like, bro, we good. And it's also that 24 into 7 into 365. You do not have to worry about it. So that part is awesome. And again, it's almost like a what you call level, a game level that is built for us, so we can brick by brick grow up to a final point. Final point would be like space. That's it. That's our domain. The end. It's like whether it has energy or does not have energy, we'll take care of it. So this is the end point of humanity, where it's like, bro, we are our own ecosystem. As in, like, where we go, ecosystem follows. And there is more than enough mass in moon to do almost everything, and it will not even make a dent into moon. Basically, we have done a lot of things on Earth, and while it feels like, oh, so much things have happened, it's negligible. It's like even ants are like, bro, the amount of mass you have moved from here to there is like negligible. Ants are like, bro, we do that in Wednesday. So moon is that kind of what you call safe material that is already in orbit, and it's enough material that it has its own station, so to say. So we have orbital station that has more than enough material to build thousands of ginormous as in O'Neill cylinder, as in like billion people kind of O'Neill cylinders, and you do not have to worry about it. So fundamentally, we got everything done. Now humans growing in space, or we will go poof, because here's deal. Anytime like, oh, what's the point? We have so many problems here. Here's deal. Earth will expire. It's an absolute fact. It's like how a child is born, that guarantees that child would go away at some point. It's just that when, like if it's 10 years, it's tragic. If it's 100 years, it's like, decently long lifespan. So that's the same thing happens with planet as in the ecosystem, the biosphere that we call so, oh, it's so cultivated for us. Like it's temporary on geological time frame. I'm not even talking cosmic time frame where basically stars come and go away. Yeah, in geological time frame, nature's biosphere is not stable. Things will happen that will kaput it. For example, what if sun sneezes, which mind you, it does regularly. We are just lucky so far that it has not directly sneezed at us. If it did, kaput. And again, supermassive volcano, it's a fixed event. It will happen. It's just so far we have been lucked out. And asteroid making love bombing dives to Earth, that will happen. It does happen. It's just that one time it will be really big one, and again, has happened in past. So these things guarantee that planet will expire at one point or the another. It could be solar system based, it could be external system based, it could be the planet itself sneezing, or worst case scenario, that is like a sniping event, basically gamma ray burst from a long kaput star, that because again that moves at light speed. Unless we detect it before the star goes nova, we will not be able to defend against it. And again, even defending is stretching it, so to say. So you get the point. Like humanity will go boom if we do not leave this planet. Now there will be two types of people. One, the bitcher people who will always bitch about us, like, oh, we have so many problems. They will die here. Like that's absurd. That's like same people who are stuck in the cave. Second group of people is like, okay, this is problem. That's awesome. Let's solve it. You have a problem, you solve it. That's all there is to it. It's like you have a problem. Awesome. That's why you go to school. That's why you learn. That's why you grow. You have a problem, you solve it. And again, brick by brick, day by day, we solve these problems. And those basically take the civilization, split them into two. One was like, oh, bitching, another solving. Even if solving has much higher death penalties, they will still survive in the long run. And again, that's why we are here. So we do not get the luxury of pressing, who cares. And again, this also gives us clean slate. Now, clean slate, you have to understand, I do not recommend deleting our history, but the fact is, we have to let go of our history. As in, like, this was early age of humans, like, how a children poops in its own diaper kind of thing. It's like, baby age. And again, there will be people who are willing to embrace science, and there will be people who are not. Those who are not, they will be stuck on the planet. Planet will become their own cage, so to say. And again, they will not miss it because it's like, this is awesome. But people who are willing to push, and again, this will not tolerate any sort of ideology or anything. It will just tolerate perfect science, perfect engineering. You have to be good at those things in order to survive. There is no, the airlocks works on like, hopes and dreams. No. It has to work on actual science. So that becomes a very good filter. Basically, only next generation of human in terms of intellectual horsepower, not only brain, but actually the ability to build something, only they can survive. So that is a very good second generation pass. It's like humanity, generation 1, Earth, humanity gen 2, which is like genuinely better than what came before, which again, you want that, you're supposed to it. Like, if I ever become a father, I would wish my children to be better than me. That's how nature's supposed to work. So this is why continuation of everything relies on humanity to taking a leap into space. The best tool to do that is basically NeillCylinder. Nothing else even comes close to that. Not going to the moon, not going to the Mars, nothing. So let's understand certain basics of it. Gravity. Now, we need gravity to do things, and I mean everything, like to pee properly, to sleep properly, to have sex properly, to most likely even make babies properly. We need gravity. Now, here's the deal. Nothing works without gravity because density loses its meaning. Density is still there. Like, if you light a candle, it has a flame. That flame becomes an oval disc in ISS whenever they light it, simply because it's like density does not know how to work if there is no gravitational force. So it's like, yeah, it does not work. Fundamentally, we need toilets, we need plumbing, and our body needs it. While astronauts on like the early days, when they like get into this, so much adrenaline, like their body is knocked out at the night. But once they start to come down to like normal daily routine, it's difficult to sleep. And I was always wondering why it's difficult to sleep. Because our body evolved to do certain flushing mechanisms internally that relies on gravity. It's almost like how our bones are built to handle gravity. Remove the gravity, bones wither away, and you end up with a lot of bones in your kidneys. Not good. Same things happens with other hormonal circuit that makes it difficult. We know that like long-term stay in space has consequences. How much consequences, that's what we are trying to figure out. And again, that's the ironic part. We have so many, like space from 1969, we still haven't figured out, can you actually have sex in space, or can you actually have babies in space? Like, and no children has ever gone to space. That again, it sounds like, oh, not a big deal. That's the biggest deal. Like, can a growing body survive in 0G, or does it need gravity? Because again, so far, all the data that we have on gravity, it's done on adult body, but bodies that are fully built, it's like, bro, we good, we got this. So, but again, if you know anything about biology, you know that like different state has different vulnerabilities. So we do not know whether babies can actually grow. Basically, we do not know what we call womb to tomb. We do not know, can a human gestate in space? Can it actually be delivered? Mother can survive that? Like, all that hassle, all that biological hormonal circuitry, can they work or not? Nothing is known at this point in time. So we do know that we require some amount of G. But here's the funny thing. What if the worst case scenario happens? Like, we actually start to try to do these things, and we find out unless you are at 1G, it just does not work. Like, adults can go anywhere they want. They can survive higher G, lower G, but you have to be in a safe environment where it's 1G, where you can have like, reproduction going on naturally. No problem. Spin the habitat to achieve your 1G. This is the most amazing aspect of it. It's a simple, it's a mathematical, it's almost like you can figure out how much like size, as in if radius from center mass is 100 meters, how much RPM you have to do in order to get 1G. Not that much. And 100-meter is not that huge. It's not. It's almost the size of the rocket, base to tip, so to say. So for 1G, you need give or take around 3 RPM. That's not that much. That's not that much. And again, if you're like, hey, we need some gravity, right? Let's say pure floating 0G is really bad, but our hormones starts to work at like 0.2, whereas density starts to work like, you need some gravity to get the cycle going. Cool. You can slow the RPM down to, let's say, 1.5. That can be done too. So this is the most amazing part of NeillCylinder. You do not get this luxury on Venus. You do not get this luxury on Moon or Mars. NeillCylinder is like, bro, we got this. And again, we have tested this. We had a space station, we spun it. And again, astronauts were running inside it. So we did test it out. We did figure it out. And it's like, yeah, it does work. Like, it's almost an invert of what we do in Vomit Comet. Vomit Comet, we simulate 0G, and does it match? Yes, it does. Here, we simulated gravity in 0G environment. Yes, it does match. So, and again, that's a Apollo 13 movie shooting in 0G environment. They needed actual 0G. CG was not that good. So they're like, hey, shoot in 0G. So fundamentally, it gives you a gravity as a tunable vector. Meaning if it's like, no, it has to be 9.8 meter per second square. Cool, GG, got this. You can have it exactly right. Or if it's like, what if you want to make superhuman? Increase it to 10 or 15. Again, why would you do that? But again, you can do that. So gravity is a tunable vector, which no other option grants you that. Now we come to the most amazing part of NeillCylinder. It has scalability, as in we can't just start and okay, we're gonna build a lithium. That's not how it works. You can't just go that. Like, you can smoke Elon, but Elon is a guy who was smoking so much. He was like, okay, in 2020 we're gonna land on Mars. I'm like, bro, no. Like, I'm not joking. Red Dragon. He was like, okay, we're gonna have Red Dragon going to. I'm like, bro, what are you smoking? That's not how it works. And be mindful, this is the same time Constellation project was in play, and look into how Constellation project was doing all those things. So, and again, yes, Constellation was designed to go to Mars. It had a puppy that was so huge that it made Starship look like a bitch. Not even joking. That's how huge Constellation's upper limit was. Not even upper limit. It was like, this is the final stage, the final form. So fundamentally, we need something that scales up. Like, how Falcon 1 was a puppy that got the ball rolling, then Falcon 9 was, well, big daddy, and then you have basically Falcon Heavy granddaddy. And then we are trying to get Starship rolling, but so far not so good result. But that's the whole point. You want things that scale. It does not want like tada, like nothing and direct 5G. That does not work. Like, you go into basically Morse code, then you go into wireless Morse code, then you go voice over wire, then you go voice over radio. Brick by brick, day by day, you build into it. NeillCylinder supports that, because at the end of the day, it just spin gravity, meaning you have to spin a puppy, and all you need to do is control the RPM to increase the gravity or decrease it. And it could be very awesome as in a training ground. And be mindful, this is from NASA only. And NASA itself had an idea, a concept. I'm pretty sure if they had a space shuttle working as intended, that would have happened. But they were like, okay, we had a spinning habitat at the end of it where people can simulate and behave as if they were on lunar gravity or Martian gravity. And it would have figured out, because I think the best use of those sort of module, a small module on a big space station, would be you go to sleep there. You go to sleep and poop and have sex there, and everything else you do in 0G. And again, that will save you so much time on exercising, because again, at night your bones will be like, rebuilt on the gravity. So that would have been awesome. And again, it can be done. It can be done. And be mindful, that diameter was not that huge. It was 10 meters. So again, very low, like something better than nothing kind of deal. But it can be done. Like, we right now with our technology we have right now, awesome things can be done. And it's just a space station with spinning materials, nothing different. Again, I do not like the idea of Elysium of having open top and you're hoping that you can exert enough pressure. Can it be done? Yes. Should it be done? Not really. Like, it can be done, it's just why? So that's the scale part of it. It scales very beautifully. Like, you start with small things and then you keep growing up. So that's the most desirable aspect of it. It's not like wait for technology to be super awesome, then only you can do it. No. Start today and you can actually have something tomorrow. Heck, this is supposed to be done in 10 years. Again, the project never went into like full production, but it's not that difficult to do in 20 years. And I'm talking with today's technology. It might be able to done much quicker than that. Now, another vector that we need to sort is docking, as in like actually attaching material. So right now, you have to understand that O'Neill cylinders are a huge puppy. Even the smaller ones that we supposed to actually simulate 1G would be so big that it has to be built in space. You cannot launch that much mass from Earth. That's just not happening. And even on Moon, it cannot happen. Even though you can do a lot more easier things on Moon, it still won't work. So that is fundamentally a very big issue. So you have to build modules in space, and right now the modules we have is we attach it, basically we send there and we just go kutung. Now that's good, that's got the ball rolling, but we need something better, more substantial. Basically we have to master making in space. Now what does making in space mean? Meaning attachment, like you actually attach it, actually bolt it on, not just like, okay, we have designed custom clamps that clamp like this, that's good and all, but to save mass and all that, you actually have to start assembling things, attaching things, welding things to make it gas tight and all that. Like, don't we get cold welding when we have like two metals touching? Yeah, but it's uncontrolled. Welding is all about control. You want metal to behave as you want it, not randomly. Welding, reinforcement, because again, if you are making a joint, you have to figure out a way to externally reinforce it. Look into any bridge closely, you will find those things. So we have to do those same thing. Again, we know the science, we know the principle, we have to do that in space. And plumbing will be a hair. Right now we do not have big enough plumbing structures to handle even 100 people of space station. Like, we just do not, like, no, like people don't even know that there is no washing machine in ISS. We have to have something significant to handle those plumbing. And be mindful, at the early construction says there won't be gravity, so plumbing has to be dealt with a zero-G environment. So you have fuel transports, water, waste, stuff, gases, power, electricity. So basically right now our current docking system, it's almost like a USB, old school USB. You had USB, you have data, you have power, nothing significant. But we need to go to USB-C, where you have bonkers high data rate, a display channel, and the ability to plug it both way, and the ability to transfer bonkers amount of power, almost 240 watts maximum. So that's the whole thing. And the most desirable part of this is that we are building this capability slowly. Like, there are experiments in vomit comet of transferring fuel. There are physical experiment in ISS where people transported fuel between two zero-G floating tanks. And if Starship ever gets actually done, that's the whole point. This will be the biggest fuel transfer, fluid transfer in zero-G environment. So we are making progress brick by brick, day by day. We are not at the inception level where we can have spinning docking, but we are making good progress. Again, let that be clear. This is the core desirable part of O'Neill cylinder. Nothing in it is like, we have no idea. Like, if you open your mouth, it's like, I want to terraform Mars. We have no idea. Here it's like, oh, this is how you do it. Like, almost like 50% of the base work is done. Now we come to the core aspect, as in, how do you scale it? As in, like, okay, making small one, cool, awesome, but how do you make the big puppies? So that requires automation. Why? Well, spacesuits are person inside a football. It's not comfortable. As in, you're like, okay, what if I put it 15 psi, everything is 15 psi, cool, awesome, GG. A person can get into and out of spacesuit very quickly. Here's the deal: nobody puts your spacesuit at 15 psi, because you will be like this. You won't be able to move your hands, because again, you are inside a football. So to make sure that it can be moved and astronaut does not tire in 5 minutes, they reduce the pressure. But again, person cannot breathe, so they remove nitrogen. So you have pure oxygen, very low pressure, as low as 8 psi, and sometimes even lower than that. But again, that creates issue that astronaut has to go through pre-breathing system and all that, because again, inside space station, normal atmosphere. Outside the space station, pure oxygen. So you cannot just jump back and forth. You want a suit, but unless we figure out exoskeleton or hard skin space suits, we cannot have like 15 psi. 15 psi in the helmet, GG, awesome. That's what we want at the other end, where you can wear a helmet and remove helmet almost like expanse. It's just like, but we are not there yet. So spacesuit reduces movement too much as of now, what we have right now. So, and it's a big hazard to keep a man alive in space, and well, because again, they have to poop and pee in their own suit. Not recommended or comfortable. So fundamentally, robots are a better solution. Even a slower machine that works 24 into 7 into 365 will outpace a human, again, not on day one, but on day 100. So let that be very clear. And again, robots would be fine-tuned just to do one thing. Like, let's say there is a robot that just does fixturing, as in holding the piece right place. Another robot only does welding. Another robot that does basically inspection. All these things can work exponentially quicker than a human can. So it is doable thing. and again, this is the actual Robonaut made by NASA, actually flown into ISS and actually tested that. Does the joints work in 0G? Does it have the same feedback loop as they were expecting? And results were encouraging. There is a bigger version of that puppy right now in construction. And this is another NASA's project where it's like, how the heck you actually build something? So they're like, okay, just build scaffolding. If you ever see any construction project on Earth, there is always a scaffolding. Why? That scaffolding allows you to do things. This is the whole point. Because here's the deal, if you do not build scaffolding, you need thrusters. It's like you have to do so much things based on thrusters. Thrusters will consume fuel, and not to mention you are also exposed. So when you build scaffolding, which mind you, this sort of technology is already sorted, it's just that we haven't done it space, but science is done. Engineering almost 50% done. So that is there. You will get free mobility, meaning if you have a chamber, right, and you want to extend it so you can make a tube into it, you create a scaffolding and scaffolding keeps moving. How a skyscraper keeps growing up, same thing will happen. And that will give you free mobility, meaning you will have robotic arms clamping and moving rather than thrusters, meaning only solar panel requirement. Safety net, meaning you can cover these things so debris is not generated and that creates an orbital issue. And temperature control, you can even cover this up with something that only lets infrared in or lets removes infrared out and only let lights in, or you can completely make it opaque so you can control the temperature better. It's all doable. And the name of the game is modularity and dexterity. The company that can design a robot that has most amount of modularity and dexterity will be the key to success, so to say. And here's the, it's a done thing. This is designed for basically lunar construction. You drop this building block which is very dense, very tightly packed, and you start assembling into blocks. Those blocks are assembled into a structure, and you have a huge structure for very little tonnage. That's today's technology. I'm not talking about something like, oh, if this, then that. No, this is here. It's done. Like, take it and go. So this is doable. And again, robotics, take it and go. All those things are already almost like we are ready. Like, parts, the toolkit is almost ready to do. So this is the core idea of basically NeillCylinder. It can be done today. We can start today, and of course we'll have Mark 1 small, basically almost like a Morse code. Then we can slowly upgrade to better and better and better and better, and eventually in hundreds of years, as in like 200 years, we will finally have structures that are huge, magnificent beasts that have like thousands and thousands of people living 24/7 on them itself. Like they will not even look at Earth as like, oh, Earth is a nah, bro. We have space where we have like actually freedom. Because again, on the surface you have gravity, in the center area you can have basically free floating, and you can go outside. And again, people are like, we can go into some other places, asteroid belt, you can go into basically lunar orbit, you can go into Martian orbit, you can go to Jupiter's, you can do so many things that is unimaginable right now. That will become unlocked to our future children, where they're like, bro, let's go to Venus, let's just go. That can be just go. So this is possible. It's not like hypothetical. It is doable. And again, all the foundational technology is already in decent stage. It's not even like, oh, if we had this. No, we have it. So this was my presentation on basically NeillCylinder part 2. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my exercise movement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.